Hi, welcome back. In this video, we're going to talk about factoring cubic polynomials. In my previous video, I showed you how to factor a quadratic polynomial, which was x squared, but for cubic, we're dealing with functions that have the highest power of x to the third power. And I will be teaching you a method called grouping. So, let's get right to it. So here I have two scenarios. I'm going to show you the first example on the left. The first thing that I want to do when I see something like this is I want to first see if they're all divisible by a common value. Is there a greatest common factor between all of these four terms that I can simplify, that I can take out? And no. 8 goes into these three, but not in the middle. So since they don't all have a common factor, what I'm going to do is I'm going to separate these into two groups. I'm going to divide this into the group of the left side and the group on the right side. And I'm going to factor them separately. So what is the greatest common factor between these two numbers? What number divides into both? Well, 8 goes into 8x cubed, and 8 also goes into 64. Now here I have x cubed, and here I have x squared. So what is the most amount of x's that fit into both? 2 x's, right? And x squared. So since there's 2 x's in at least these two sides, I'm going to put this as x squared. We call this the GCF because it's the greatest common factor between these two terms. Now, to find the other factor, I'm going to divide everything by the GCF. And as you can tell, the 8 divided by 8 cancels to 1. And then notice how down here we have two x's, x squared and x cubed, right? So when I divide exponents, remember, when I'm dividing, I'm going to be canceling the values. So I get to cancel 2 of these values. And I'm left with just 1 on top. So x cubed divided by x squared is just x. Now similarly, what's 64 divided by 8? Negative 8. And x squared divided by x squared cancels nicely into just 1. So on the left, I was able to factor out an ax squared from both terms. On the right side, what are they both divisible by? I want to factor out a term from both of these. Now, since they're both not divisible by anything like 2, 4, 6, or 8, I'm going to factor out a positive 1 because everything's divisible by 1. If I factor out a 1, I'm just going to divide both sides by positive 1. X divided by 1 is just x, and 8 divided by 1 is just negative 8. Now, notice how these two, the problem was divided into two groups, right? Now these two groups, the one on the left and the one on the right, have something in common. And they always will for this method. They both have an x minus 8 in both groups. I have group 1 and I have group 2. What do they both share in common? X minus 8. Now, these two groups, since they have x minus 8 in common, I'm going to divide x minus 8 on both sides. Just like I did up here, I divided both by an 8 because 8 fit into both. X minus 8 fits into both. And when I do that, these cancel nicely, being my first factor, and the second factor is whatever's left over, which is 8x squared and positive 1. And these are the factors of my cubic polynomial. If I want to do FOIL or box method, I would end up being back in square 1. Now, what does this mean? Well, usually when we factor something, like let's say that we're factoring x squared plus 3x plus 2. The factors of this quadratic would be x plus 2 times x plus 1. These are just the factors of the quadratic. If I were to solve this problem, and let's say that the function equals 0, if I were to solve the equation, I would end up getting x equals negative 2 and x equals negative 1. What does that mean? It means that if I were to graph a parabola, in this scenario, the quadratic would have two solutions, or two x-intercepts. at -2, and at -1. So what does that mean for this cubic? It means that if I were to continue with the products, once I find the factors, if I were to keep solving them, I would end up getting this general cubic function that would have 3 possible x-intercepts. 2 of them would be here, and 1 of them would be here. But we'll save that solving for the x-intercepts for another video. For now, we just want to get comfortable factoring the polynomial. This is just a quick heads up of where we're going eventually. Okay, example number 2. As you can see here, what do these two have in common? Well, none of the numbers, like they're not all divisible by 2 or by 3 or by 4. In this case, I would have to just focus on half the problem. On the left side, what do these two have in common? Well, 3 goes into 12 and 3 goes into 21. So 3 is my greatest common factor, as well as with my x squared. Because there's an x squared in here and an x squared fits in here as well. So I divide both sides by 3x squared, my GCF. And when I do that, 12 divided by 3 leaves me with 4. X cubed divided by x squared leaves me with just 1x, right? Because one of them is going to cancel. I have 2 on top, 2 on the bottom, and there's 1 left over up here. And then 21 divided by 3 is -7. And notice how these x squares cancel completely. Okay, similarly, on the right side, what do these two have in common? Well, they're both divisible by 7. A positive 7. In a few examples, I'll tell you how I know that it's a positive 7, a positive 1, or whether it changes to -7. How do we know that? I'll show you here in about 2 more examples. So just hang in there, or click ahead. If I divide both by 7, 28 divided by 7, I get 4, and then the x comes down. And then 49 divided by 7, it's just -7. Notice how I have a 4x minus 7 and a 4x minus 7. In this particular step, you will always find these parentheses to match. If they don't match, we have to go back and see if we divided by the right number. Because this is the whole purpose of grouping, is that you can do it in 2 separate parts, and both parts, the left and the right, will share something in common. So the thing they have in common will be my first factor. I divide the left by the first greatest common factor, and I divide the right by the greatest common factor. And when I divide them, I'm left with 3x squared and positive 7. And these are my factors. Okay, so here we have our last 2 examples. I strongly recommend that you hit pause and that you try the problems yourself. Try them out and then click play and see if you're doing the first step with me correctly. And then press pause again and try the next step and just kind of see how you're doing, right? Because seeing the problem is one thing, but solving it by yourself is another. And that's where you get better, where you start practicing by yourself. What is it that you're understanding and what is it that you don't? So give it a try. Now here, it looks like they're mostly even numbers, but this one is not an even number, so they're not all divisible by 2. I can't really factor anything. Let's say that we could factor something. As an example, let's say that we had something like 6x cubed minus 16x squared plus 20x minus, let's say, 46. If this was the problem, and they're all divisible by 2, the way that I would approach this problem is that I would first factor out a 2. Divide everything by 2 to simplify the problem. I would be left with 3x cubed minus 8x squared plus 10x minus 23. And then I would solve the inside of the parentheses like I would do these problems. And then my answer in the end would just have a 2, and then my 2 factors that I would be finding. Just in case you see something like that in the future. All right, back to our examples. I'm going to divide this into 2 parts, the left side and the right side. Group 1, they both are even numbers, so they're both divisible by 2, and they both have at least x squared in both of them. So when I divide by the GCF, 6 divided by 2 gives me 3, and then x cubed divided by x squared gives me x. On the second side, 16 divided by 2 gives me 8, and it's a minus 8. And then the x squares cancel out nicely. On the right side, what do these 2 terms have in common? Well, 7 goes into both of them. I'm going to do a positive 7. So when I divide the left by 7 and the right by 7, I get 3x and then negative 8. Notice how we have the parentheses the same for the both groups. We're always going to get that, okay? So the first thing I do is I take, what do these 2 groups have in common? Well, the left and the right both have 3x minus 8 in common. And just like I divided both by 7, or both by 2x squared, these 2 groups will be divided by the thing they share in common, the GCF. And when we divide them, these nicely simplify to 2x squared on the left and a plus 7 on the right. The idea again here is that we are separating the whole problem into 2 parts. Find the GCF of the left, find the GCF of the right, and then you'll realize that the 2 groups will share something in common. And that same thing that they have in common, we will factor it out, and then when we divide both parts, we're left with the other factor. Let's give this next one a try. Okay, on the left side, first of all, they're not all even numbers, or they're not all divisible by 5 or by 10 or by 3. So I don't have to factor out a 2 or a common factor to begin with. So they're both even. I'm going to take out a 2 and x squared from the problem. On the left side, when you divide by 2x squared, 12 divided by 2 is 6, and x cubed divided by x squared is x. Right? Because I have 3 x's on top and 2 x's in the bottom. And when I divide them, I'm left with just 1x. That's how I get that number. Now on the right side, they're both divisible by 5. Now notice how here, when I divide both by 5, I'm going to end up getting a negative 30 divided by 5 is negative 6x, and negative 5 divided by 5 is a negative 1. Over here, when I divided the 2 divided by 2 and x squared divided by x squared, I get a positive 1. But over here, I get negatives. So they're the same numbers in the parentheses, except that the signs are the opposite. So how do we address that? How do we fix that? Well, instead of just dividing by a 5, I'm going to divide it by a negative 5. And when I divide by a negative, negative divided by a negative turns this number into a positive. Right? And similarly, negative divided by a negative turns this into a positive. And now notice how the parentheses are exactly the same. They match. So whenever you get a scenario that they don't match, check the signs. Do we need to divide it by a negative? If so, you factor out not just the 5, but a negative 5. And then the rest stays the same. What do these 2 groups have in common? The 6x plus 1. So when you divide both groups by 6x plus 1, we're left with 2x squared minus 5. Yeah. So the only difference here is I have to consider a negative. How did I know that was going to happen? Well, look at this previous problem. When I split this into two groups, you see how they both have negatives? I have a negative here and a negative here. So the signs stay the same. They're both minuses. But here, when I divide this into two groups, the left side gave me a positive number, gave me a plus in the parentheses, but the right side had a negative, which that sort of gave me a sign that it wasn't going to work out because the signs were opposite. So these were already not going to match with the signs. Yeah? And you can look at our previous examples as well, right? As you look at the previous examples, look at the left side. The two parts, the left is minus, the right is minus. So it works out. Over here, they're both minuses, so they match. So the problem can have all positive numbers, all negative numbers, but when the minute you start to switch into positive and negative is when you're going to start to watch out for that negative symbol there. All right, guys, I hope this has helped. Please let me know if you have any questions. Don't forget to like and subscribe. And as always, we'll calculate.